Okay, moving on in week number 10. Yes, I'm losing track of what weeks we are. So this is our second last week of learning new stuff. This week we're going to learn multiplying and dividing of rationals, and next week we're going to learn adding and subtracting of rationals, and then our last week is a review assignment. All right, so we're going to start with multiplying and dividing rationals. So multiplying and dividing rationals is actually quite easy if you understood the simplifying lesson, because it's just like simplifying twice. So if you can simplify, multiplying and dividing is very easy. So steps for multiplying rational expressions. Factor the numerator and denominators of both expressions. Identify the non-permissible values always before you cancel. Then simplify. Anything on the numerator that cancels anything on the denominator can go. And then multiply the numerators and multiply the denominators, writing them as the product of a single rational. And then always check to see if you missed anything. All right, so example 1. Simplify the following rational expressions and state non-permissible values. So the very first thing we have to do is GCF, or difference of squares, every numerator and denominator. Now with simplifying, we just had one numerator and one denominator. We did that. But with multiplying, we actually have two numerators and two denominators, so we have to do it to all of them. So I look at the x plus 1 and I say, can I take anything out of there? And I can't. So I just rewrite it as x plus 1 in a bracket because it's attached with that plus sign, so that means that it's one term. Well, not one term, there's two terms, but they're attached to the plus sign, so it can only cancel if there's an exact match. Okay, the bottom denominator, the bottom left denominator, is x plus 3. I can't take a GCF out of that, and it's not a difference of squares, so I just rewrite it with brackets because it's attached to that plus sign. Then the dot means multiplication. And why do they do this dot? Because a multiplication symbol looks like an x, and then it gets super confusing. Okay, the numerator on the right, or the top on the right, I can take out a GCF of 2. When I take 2 out of 2x, I'm left with x. And I take a 2 out of 6. 6 divided by 2 is 3. And then the 2 out front can just go in its own bracket. The bottom right denominator, I have x squared plus x. I can take an x out. When I take an x out of x squared, I'm left with x plus, and remember, x divided by x, I'm left with a 1. So remember that 1 has to be there, okay? So if you take a GCF out of two terms, you should still have two terms left over. Now I see that there's stuff I can cancel, but I'm not going to do that. First, I'm going to state my non-permissible values. Not sure why I'm writing it out. I'll take short form. Diploma, we would write out non-permissible values, but for me, I take NPVs. The catch with multiplication is now I have two denominators, so I have to state non-permissible values for every denominator, for this one, and that one. So I take each bracket, all of the denominator brackets, and set them equal to 0. So I have x plus 3 cannot equal 0. I have x cannot equal 0. And x plus 1 cannot equal 0. Then for this one, I'm going to subtract 3 from both sides. And I get x cannot equal negative 3. This one's done. X cannot equal 0. This one I'm going to subtract the 1 over. And I'm going to have x cannot equal negative 1. All right. Now, what I can do with multiplication is I can actually now just take this line and draw it completely across and connect the tops to the tops and the bottoms to the bottoms. Now, anything that matches on the top and the bottom can cancel. Remember, it has to match exactly the same when it has a bracket with a plus or minus sign. So x plus 1 completely matches the other x plus 1, so it can cancel. X plus 3 completely cancels off the other x plus 3, and all I'm left with is 2 over x, and nothing cancels there. So I get 2 over x, and then I say, am I missing something? Can I cancel more? No, I cannot. So I just state my NPVs. X cannot equal negative 3, negative 1, and 0. And hit box it. There's my answer, simplified version of the multiplication. So it'll just say simplify, and you know you need to multiply because there's a multiplication symbol. Let's go to B. B is a little more complicated. So I look at the numerator. The numerator is two numbers multiplied, so I can't GCF that. So I write the 12 in a bracket and the x cubed in its own bracket. Then the bottom left, I have 3x squared plus 6x. I can take a 3x out as a GCF. I take a 3x out of 3x squared, I'm left with x, plus 6x, take out 3x, I'm left with a 2. The x plus 2 sits in its own brackets, and then the 3 and the x go in their own brackets because they're multiplied, not attached by plus or minus sign. Then the top right numerator, I have 4x cubed plus 8x squared. I can take out a 4 and an x squared. When I take 4x squared out of 4x cubed, I'm left with x, plus 8x squared, take out 4x squared, I'm left with a 2. And then the 4x squared is multiplied, so they can go in their own brackets. And then I just have a 5 in the bottom. And before I go to cancel, I always, or put the tops together and the bottoms together, I have to find my NPVs. So I have 3, I have x plus 2, and I have 5. So I'm going to say 3 cannot equal 0, which is true, but doesn't get me an NPV. Then I say x cannot equal 0. Then I say x plus 2 cannot equal 0. And I also say 5 cannot equal 0, which is true, but doesn't get me an NPV because it doesn't have a variable. X cannot equal 0 is done. This one I'm going to subtract 2 from both sides. I'm going to get x cannot equal negative 2. So I have two non-permissible values. Then I can go back and connect the top and the bottom. And I see what I can cancel off. I have an x plus 2 in both the numerator and the denominator, so that can go. I have one x in the bottom. So this one x can cancel off one of these x cubes or one of the x squareds. Either way, if it cancels off one of the x cubes, I'm still left with x squared. And then if I think I'm done, I can multiply them together. So I go 12 times 4 is 48. X squared times x squared is 2x's and 2x's, so I end up with actually x to the 4. And then on the bottom I have 3 times 5, which is 15. Then I say, can I take anything out more? Actually, I can. I can take a 3 out of both 48 and 15. So if I take 48 and I divide it by 3, I get 16. So I'm going to get 16 on the top, 16x4. And I take a 3 out of 15, I get a 5. So I'm going to get 16x4 over 5. And I have to go behind with my NPVs. X cannot equal 0, comma, negative 2. And that's it. That's all we do for all the multiplying. So we're going to practice a whole bunch. So let's look at C. The left numerator, I have 2x cubed minus 4x squared. I can take a 2x squared out. When I take a 2x squared out of 2x cubed, I'm left with x. And when I take a 2x squared out of negative 4x squared, I'm left with negative 2. And then the 2 and the x squared can go in their own brackets because they're multiplied. Then I look at the left denominator, 3x squared minus 9x. I can take out a 3x. I take 3x out of 3x squared, I'm left with an x. When I take 3x out of negative 9x, I get negative 3. And then the 3 and the x can go in their own brackets. Multiplied, x squared just stays x squared. The bottom here, x squared minus 4 is actually a difference of squares. Because if I take x squared minus 4, I have two terms. Square root of x squared is x. The square root of 4 is 2. So I'm going to get x plus 2, x minus 2. And then before I cancel anything off or put the numerators and denominators together, I have to state my NPVs. So it's with the 3, the x minus 3, the x plus 2, the x minus 2. So I have 3 cannot equal 0, not an NPV. I have x cannot equal 0, that one's done. I have x minus 3 cannot equal 0. Add 3 to both sides. So I get x cannot equal 3. I have x plus 2 cannot equal 0. Subtract 2 from both sides. X cannot equal negative 2. And I have x minus 2 cannot equal 0. Add 2 to both sides. X cannot equal 2. Okay, I have all my NPVs. So with all my NPVs, I can now go back and I can connect to these. And I can say, is there anything in common? Well, I have an x minus 2 and an x minus 2. I have a single x, which I can cross off one of these x squared x's and put a 1. And then I think that's it. So let's see what's left over. So I have 2. And then x1 times x squared is x to the 3 because you add the exponents. So I have a 2 and an x3 over 3 x minus 3 x plus 2. And that's all I can do because I have an x minus 3 in the denominator, but I do not have an x minus 3 in the numerator, so it's staying. I have an x plus 2 in the denominator, but I do not have an x plus 2 in the numerator, so it's staying. I have an x cubed, but no single x's in the bottom. And a 2 and a 3, there's nothing I can take out of those numbers, so it's as low as it can go. I just have to state my NPVs behind. So x cannot equal 0, 3, or positive, negative 2. And we're done that one. Next page. Oops. All right. So simplify the following product. Product is an answer to a multiplication statement and state non-permissible values. We always state NPVs. Okay. So what are we going to do when we multiply? Same steps over and over and over. GCF, difference of squares, all your numerators and your denominators. So I look at the 2x squared minus 12x and I say to myself, I can take a 2x out of that. So I go 2x, what was my equal sign? 2x. And then I'm left with 2x squared divided by 2x is just x. And then negative 12x divided by 2x is negative 6. Brackets on the 2 and the x. And then I have 15 and x that I can put in separate brackets because they're just multiplied. I have a 5x in the numerator, so I can go 5 and x because they're multiplied. And then x minus 6, I can't take anything out of it, and it's not a difference of squares, so I just write it in brackets. Then before I put it together, I always have to state my NPVs. So I'm going to say 15 cannot equal 0. And I'm going to say x cannot equal 0. That's actually an NPV. And then on the right-hand denominator, I have x minus 6 cannot equal 0. Add 6. X cannot equal 6. Then I can put the numerators together and the denominators together. Draw a straight line through it. Now all the numerators are together and all the denominators are together. And if there's something that's the same, I can cancel. So x minus 6, x minus 6. I have one x in the top and two x's, or two x's in the top, sorry, and one x in the bottom. I can only cancel one for one. So I'm going to cancel this x off with this x. And then I think I'm done. So I'm going to write what's left over. If there's two numbers separately in brackets, you put them together by multiplication. So I go 2 times 5 is 10x. And then on the bottom, I just have 15. And the 10 and the x can go in their own brackets because they're multiplied. And I say, wait, I can say take something out of the 10 and the 15. I can take out a 5. 10 divided by 5 is 2. 15 divided by 5 is 3. So I get 2x over 3. I have to state my NPVs. X cannot equal 0 and 6. And then this is your last multiplication one. And then you can practice your textbook questions. So like I said, if you were good at simplifying, this is easy for you. If you didn't understand simplifying, I sure hope you messaged me and asked me to sit on Zoom, or not Zoom, Google Hangout Meets and help you. If you have gotten to this point and you're like, I still don't know what I'm doing when we're done this lesson, please message me and I can go through it with you one-on-one and make you understand it, okay? So please don't just struggle. You can email me and I can email you back, or you can email me and I can meet you on Google Hangouts and we can learn it together, okay? So please don't just sit there and struggle. If at the end of this you're like, I have no idea what you just did, then please message me, okay? So let's do the last one. With the appropriate restrictions, the product, and product is just an answer to multiplication. So you just want the answer. The product of 2x minus 24 over 3x squared minus 12 times 6x plus 12 over 2 reduces to a whole number. Remember we talked about whole numbers? Whole numbers are the one that starts with a whole. So 0 and then goes on, 0, 1, 2, 3, 4, etc. It reduces to a whole number with the value of k, and then they just want the value of k. What would k be? So they basically just want us to multiply, and it's going to work itself out to get rid of all the variables. So we have 12x minus 24 over 3x squared minus 12 in brackets 6x plus 12 over 2 in brackets. So that's just the same as going equal to 12x minus 24 over 3x squared minus 12 dot 6x plus 12 over 2. It's the same thing. So we look at the top and we say, what can we take out? Top left, the numerator. 12x minus 24. We can take out a 12. We take a 12 out of 12x. We're left with x. Negative 24 divided by 12 is negative 2. And the 12 can be in its own bracket. We look at the bottom. We have 3x squared minus 12. We can take a 3 out. And we're left with x squared minus 4. Top right, we can take a 6 out. And we're left with x plus 2. Because 6x divided by 6 is x. 12 divided by 6 is 2. And then a 2. Now there is a catch here. X squared minus 4 is actually a difference of squares. So we can keep going on that bottom. X squared minus 4, if I take the square root of x squared, it's x. And the square root of 4 is 2. And there's a difference sign. So I'm actually going to get x plus 2x minus 2 in the bottom. So I'm going to do that. I have 12 and x minus 2. That doesn't change. The denominator on the left, though, the x squared minus 4 changes to x plus 2, x minus 2. So you have to watch. After you take out a GCF, sometimes there's a difference of squares still there for you to deal with, okay? 6x plus 2 over 2. And often, if you can't figure out anything to cancel, it's because you're missing a difference of squares. Go back and look for your difference of squares that you didn't maybe do. Okay, before we cancel, we have to state NPVs, because that's the rule. So we have 3 cannot equal 0, which is true, but not an NPV. X plus 2 cannot equal 0. Subtract 2. X cannot equal negative 2. X minus 2 cannot equal 0. Add 2. x cannot equal 2. And then we have 2 cannot equal 0, which is true, but not a non-permissible value. So these are only NPVs. Then we can write our numerators and denominators together by drawing the line across and see what we have in common. X minus 2, x minus 2, x plus 2, x plus 2, and then I write what's left over. 12 times 6 is 72. Yeah, 72. And then on the bottom, I have 3 times 2, which is 6. And then I can go 72 divided by 6 in my calculator, and I get 12. So my answer is 12. And if we filled it into a numeric response box, we fill from left to right. So we'd go 12. So that is your notes for multiplication. So now you can go to your textbook and work on the questions. And you can also go to the assignment after you've worked on the textbook questions and check to make sure you had them right. Then you can go to the assignment and do the multiplication questions. Hope you have a great day. Miss you guys.